Good afternoon, Brian. How are you doing this afternoon? Can you hear me, Brian? Okay. Thought you weren't there for a second. Okay. This week, week number 10, we're going to be solving systems of equations with three equations, which makes it a little bit more difficult to solve than with two variables. What we want to do, there's like six steps here. Step number one, we want to write all the equations in standard form, cleared of any decimals or fractions. We don't want to, so we want to write each equation in standard form. We want to make sure there's no decimals or fractions. Step number two, we want to choose a variable that we want to eliminate. And it can be any of the variables. It can be the x, the y, or the z. It does not make any difference. Step number three, we're going to select a different set of two equations and eliminate the same variable as step number two. So step number two, we're going to choose a variable, and then we're going to eliminate it in two of the three equations. And then step three, we're going to eliminate that same variable, but we have to use the one equation that we did not use in step number two. Step number four, we're going to solve the two equations from step 2 and 3. So that basically takes it down to like last week's assignment where we have two variables we have to solve. And then step number 5, we're going to substitute back in. And step 6, check. Okay, so let's work on a problem like this. This is our first practice problem. It says determine which of the ordered pair of triples below is a solution. Now we're going to work through the whole problem, okay, and these do take a while. So they are ready in this problem. They are ready in standard form. We've got our x's, our y's, our z's all lined up, and that's what we want. We want all of our variables lined up. Then we have to decide which variable we want to get rid of. Now, I'm looking at the z's, and I have a positive 2z here and a negative 2z here. So I'm going to call this equation 1, 2, and 3. So what I'm going to do is I'm going to add equations 1 and 3 together, okay? So 4x plus y plus 2z is equal to 13, and 6x plus 4y minus 2z is equal to 22. Now, when I add these two together, 4x and 6x, that gives me 10x. 1y plus 4y gives me 5y. But the z's cross off, and that's what I wanted. I want to make sure one of the variables crosses off, is equal to 35. Okay, so that was equation 1 and 3. Now, I have to get rid of the z in equation 2 because I haven't touched equation 2 yet. I have to get rid of the z, so I can add that to equation 1 or equation 3. It does not make any difference. I'm going to add equation 2 and 3 together, okay? 2 and 3. Now, obviously, equation 2, we have 8x plus 3y plus 6z is equal to 35. The z's are not going to cross off if I just add straight down. This has to become a negative 6z. So what I'm going to do is I'm going to multiply this equation every single term by 3 before I add. So 3 times 6x gives me 18x plus 3 times 4y, that gives me 12y, plus 3 times negative 2z gives me negative 6z, is equal to, what is that, 66? I have to multiply to 3 all the way across also. Now if I add straight down, the z's are going to cross off. So I'm left with, what, 26x plus 15y is equal to, what is that going to be, 101? All right, so I'm going to call this equation A and this equation B. We got rid of the variable z in both these equations. So now it's very much like last week. I'm just going to write equation A over here. That's 10x plus 5y is equal to 35. And equation B is 26x plus 15y is equal to 101. Now this is just like last week. We've got to get rid of one of the variables now because we're down to two equations, two variables. So I can get rid of one of the equations. I'm gonna multiply the top equation by 3. Why am I doing that? Or I'm gonna do by -3. And why am I doing that? Well, guess what? I want to get rid of the y's now. So if I have -15 here and a +15 here, cross out. So I've got -30x plus -15y is equal to 35 times 3 is at 15, 105, -105. So now if I add straight down, -30x plus 26x, that's -4x, is equal to -105 and 101, that's -4. So x equals 1. So all of that work, and I finally end up with one of my variables. And when we write out variables, they should be in order triple. So my x value is 1. So now how do I find the rest of them? Once we're to this point, it's really easy. Because now in order to find the y value, all I have to do is put 1 in for one of these two equations. So 26 times 1, so that's going to be 26 plus 15y is equal to 101. If I subtract 26 off there, I end up with 15y is equal to 101 minus 26, which is 75. And then if I divide through by 15, I end up with y is equal to 5. So now I have two of my variables. I have my y value and I have my x value. Now to find out my z value, all I do is I go up to the original equations, pick one of them out. So I've got, let's go with the first one, 4x plus y plus 2z is equal to 13. And I know x is 1, so I'm going to put 1 in. Oops, I wanted to change color here. So I'm going to put 1 in for x, and I know my y value is 5. So 4 times 1 is 4, plus 5 plus 2z is equal to 13. That's 9. I'm going to subtract 9 off of both sides, so 2z is equal to -4, or to just 4. So z is equal to 2. So my answer should be 1, 5, and 2. This is, you know, when you have three systems of equations with three variables, it is kind of complicated to do those types of problems, but you have to follow the steps. You have to get two of the equations, and you have to get rid of the one of the variables, and then you have to get rid of the other variable. So you're going to solve for all three. Brian, does that make sense? Okay, now that's the first problem on the practice. The second problem is much easier. This problem is so much easier, and the reason it's so much easier is we already know what the z value is. That they kind of gave us a head start here. They already told us z. So if I'm doing my x, y, and z, so I know z is 2, so I can put that in there. Now, if I plug z in here, I know z is 2, so I'm just going to plug it in here. So that leaves me with 9y plus 2 is equal to 29. Subtract off the 2, so 9y is equal to 27. Y is equal to 3. So now I have two of my variables. And then the last one, I just have to put the y and the z in. So I end up with 5x plus 2 times 3 minus 7 times 2 is equal to -13. And I just have to solve this. So 5x plus 6 minus 14 is equal to -13. What is that going to be? -8. So I'm going to add 8 to both sides. So 5x equals -5. X equals -1. So this one was much easier because we already knew what one of the variables was. So all we have to do is just, it's called back substituting the problem in. So my answer should be letter C here. All right. And there's only 3 problems on the practice this week. Yay! But the third one, this one is very much like the last problem on the assessment. So this problem here, it says, find the equation of the parabola y is equal to ax squared plus bx plus c that passes through the points. This is exactly the same problem. Well, it's not the exact same problem. The points are a little bit different. But what we have to do is we have to write out the three equations first, and then we have to solve the system of equations. So how do we write out the equations first? Well, we know that the equation is, for a parabola, is y is equal to ax squared plus bx plus c. And in this problem, they give us 3 points. Well, this is my x value and this is my y value. So if I write out my first equation, I put 4 in for y, so this becomes 4 is equal to a, I don't know what a is, but then I put the number in for x squared. So negative 1 squared is 1 plus, and then bx, well, the x value is negative 1. I'm just going to, I should have written this. 4 is equal to 1a plus negative 1b. I always put my, and then plus c. Well, we don't know what c is. It's just, so we just leave c. Then my second equation is 0, 5. So I'm going to put 5 in for y. So 5 is equal to, and then 0 in for x. So if I put 0 here, 0 squared is 0. So this becomes 0a plus 0b plus c. So guess what happens here? 0a and 0b just cross off. So lo and behold, we already know what one of our variables is. C is equal to 5. And then my last equation, 1 and 2, so I put 2 in for y. So this becomes, so I'm just going to write my 3 equations over here. 4 is equal to 1a plus negative 1b plus c. And 5 is equal to c. That's, I love this one because now we already know what one of our variables is. And then 1, 2, so I'm going to put 2 in for y. So this becomes 2 is equal to, and then if I put 1 in for x, that gives me 1a plus 1b plus c. So we already know what our c value is. So we can plug that in, and that would be my next step here, is I would just plug 5 in for c here. 5, 5, and then I'm going to subtract it off here, because if I subtract 5 from 4, that gives me negative 1 is equal to 1a plus negative 1b. If I bring 5 over here, that gives me negative 3 is equal to 1a plus 1b. Now, I want to solve for a. Let's say I'm going to solve for a, because if I add straight down, the b's are going to cross off. So this gives me negative 4 is equal to 2a. So a must equal negative 2. So now I have my a value, negative 2. I have my c value, which is 5. All I have to do is find my b value. So all I'm going to do is I'm going to go up here just to one of these equations to figure out what my b value is. So I'm just going to take the negative 3 is equal to 1a plus 1b. And oops, yep, that's correct. And I'm going to put negative 2 in here. So negative 3 is equal to negative 2 plus b. Bring the 2 over here. B is equal to negative 1. So now, if I want to write my equation, here's my equation. So y is equal to negative 2x squared plus negative 1b plus 5. So that leaves me with negative 1b, or I'm sorry, that shouldn't be a b there. That should be an x, because the negative 1 was my b value. Sorry about that. So negative 2x squared plus negative 1x plus 5. So negative 2x squared plus negative 1x plus 5. So my answer should be letter B. This problem right here is just like number 4 on the assessment, where you're given 3 ordered pairs. You have to write out the equations and then come up with your equation for the parabola. So the rest of the assessment this week is fairly easy. It just, well, I shouldn't say that, because solving a system of equations with 3 variables is not that easy. It does take patience, and it takes a lot of patience, because you have to try to get rid of those variables. Any questions, Brian? That was the only 3 practice problems that we have for this week. So you are more than welcome to go, or if you want to stick around and ask some questions about any of the other material you've been working on, you are more than welcome. Have a great week. Bye.